Hello everybody and welcome to the third session of the second week of the Angular web development course. In this session, we'll try to understand what is the architecture of Angular and what are the basic building blocks of Angular. Now let's try to understand what is the architecture of Angular. As you may see in the image which is provided over here, this represents the high level architecture of Angular. Don't worry if you don't get it or it is too intimidating. We'll try to break this down in the following slides. Okay. So the basic building blocks of Angular can on a high level be divided into these four classes. One is the components, the second is the templates, third is the directives, and fourth is the dependency injection. Now let's try to understand it. When I say the architecture of Angular can just be divided into these four things, what I mean by that is if you see the image over here at the center, you would see there is something called a template which just has kind of a HTML tag, and you have something called a component, and in between there's something called a metadata, right? And in that template there is a kind of a dependency on directive which again has a metadata, and on the left hand side you would see there is something called modules at the top and injector at the bottom, right? So now we'll try to understand this conceptually. So if you see any application, right, the main thing on the application which we see on the screen is nothing but the template, right? So the template is nothing but the HTML tag or the HTML script which you write and which is being shown to the user. And for this HTML template to work, we need some data, right? And also we need to attach it some event whenever user clicks something, we need to fetch something, show it on the screen, so on and so forth. And to do all that, we have something called a component. So at a basic level, you can say a component is nothing but it is having one HTML view, and also it provides you additional features to handle any user interaction or other things which you want to do, right? And in between, you have something called a metadata. I will come to the metadata at last, but for now, just stay on with me. You will also see in this template, there is like a dependency which is created for directive. So what is a directive? So basically, when you see a component is nothing but it is a collection of HTML and your logic of the that particular screen which you need to handle. But a directive is nothing but it does not have its own HTML page, right? A directive is just a standalone TypeScript file which can be attached to any HTML file and you can add any features to it. I'll give you one example. Say for example, you type, like you would have seen a lot of website when when you type your date of birth, like when you just type 2408 and 2020. So what happens is automatically that input will add slashes or line dashes for you. So that is nothing but an example of directive wherein you want to add certain features to your HTML file, but you don't really want to have a full-fledged component out of it, but rather you can have a standalone file out of it. So that is called directive. Don't worry if you don't understand it, because we will be covering all these concepts in depth in the future course of time, right? So for now, just understand that a component has its own HTML and the logic, whereas the directive just has the logic for the manipulation of the HTML, but it does not has its own HTML. But it can be added to any HTML file. Okay. And next we'll come to what is the metadata which you see over here. See, understand one thing. When we write program or any logic in TypeScript, end of the day, those are nothing but class, right? As you know, TypeScript is an object-oriented language. So anything that you write in TypeScript is nothing but end of the day, it's a class. And class, is just a simple, kind of a object which is used by any program to do certain operations. So what a metadata essentially does is it tells the Angular CLI application that this particular class that you are encountering is not just a normal class, but rather if you there is something called the concept of a decorator, using which you can say that this particular class is of the type component and these are the properties, and that properties are nothing but the metadata. And similarly, if you have something like a directive or a pipe or a service and so on and so forth, each of these has its own metadata. So metadata is nothing but in a simple language, it just means the information about the data which you have, right? I'll just give you a simple example. Say I give you a a box, just a real world example, and it is closed and there are some items in it. And you just wanted to need to know what are the things that are present in the box. So what I can do is I can just stick a label on top of that box and I can say these contains maybe chocolates, and those are of the types of toffees, candies, and they can be of that color red, green, and they're of the brand of say XYZ, ABC, so on and so forth. So what I'm essentially doing is I'm just describing what is present in my box. So that is nothing but the metadata. It just gives you some additional information about the data that is being there. And on the left hand side, you see something called as injector. So what is this injector concept is and the service concept is? For this, we need to understand a bit about dependency injection. And for that, I'll be going to the whiteboard. Now let's try to understand what is dependency injection, right? Or DI as it is called. So this is a design paradigm which is used in software architecture development. So wherein I'll just try to first make you understand what it is. So in a classic sense, right? Say I have something like a class A and it depends on class B. So what I mean by that is, say for example, my class B requires to implement some feature from class A. So what I need to do is I need to first instantiate this class A into my class B, and then I need to do any operation that I require to do, right? So what happens is this instance of the class A is first created, and then only I'll be able to access any objects of class A inside my class B. But what happens in dependency injection is we move that all that thing of instantiating and all that heavy lifting that we need to do to a third party service. So let me show you how it works. So the same example, say I have now class A which is used by class B, right? So this is my dependency. But instead of directly instantiating class A and class B, I will be having something called as an injector class. Okay. So what happens is my class B would be calling this injector class for class A, and this injector class in between would be doing all the instantiating work and all that importing work for me, and so that my class B can directly use class A without being bothered about how should I instantiate it, how should I call it, and all that thing. So this is the pattern of dependency injection, right? So basically in dependency injection, you would see there are three aspects. One is the this thing which is called my client. Second thing is nothing but my service class, and third thing is nothing but my injector class. So this is what is the dependency injection looks like. And now you may have this question what is the advantage of using dependency injection over the normal way of instantiating the class? So the first thing is since you are decoupling both of your class and you're making it kind of independent, it is really easy for us to write unit test cases for it. That is the first advantage. Second thing is since you're not instantiating too much and you're not repeating your code too much, the boilerplate code which you need to write to do all this process is greatly reduced because you just need to import this. And as I said earlier, just by writing one line of code, you kind of reduce a lot of code which you can write. And it becomes easy for you to extend your application and write and introduce new features easily, because since you are not tightly coupling class A with class B, you are not coupling your client with your service, you can independently update them and evolve them in parallel without rather being worrying what if happens if I touch this and this gets broken, as long as you're following certain basic rules of it. And finally, as I said, due to this, what happens is your application is totally decoupled. So what I mean by decoupled is, so let me give you an example. What do I mean by decoupled? Say I have a class A and or maybe a file A or an object B, right? And I need to develop both of these, and they also internally have some dependencies. Okay. So if it is tightly coupled, what it means is any change to class A will directly impact my class B, and I also need to update class B. Whereas if it is decoupled, what it means is even if I change anything on my class A, it will not really affect my class B. I'll give you a simple example. So say I have say a client class which is called say maybe get name. Okay. And I have a service which gives me take name. I'm just making up some name over here. So what happens over here is they assume this is my class which tries to make a call depends on this particular service to fetch some name. Okay. And the rule or either protocol that they follow is every time this class calls this service, there will be something there will be a variable which would return the name in this format. Name is equal to say some name. Okay. So what happens is, since we have decoupled this using dependency injection, even in future, I can keep on updating my get name to have a ton of functionality, and similarly for take name for it to have a ton of functionality. As long as my get name is able to get this name variable from take name service, and it is able to get that properly, I don't bother what are the other things that get name is doing or what are the other things that take name is doing. I can involve them parallelly, independent of each other, and using the injector and dependency injection concept, I will be able to make all of these work together. So this is what is the concept of dependency injection. So coming back to the architecture, you would also see that on the left hand side there is something called module component, module service, module value, module function, so on and so forth. So what it means, let again go back to the whiteboard to understand it. So as let's come back to the same Amazon or Flipkart or any other website that you know of, right? So if you take any website for that matter, what are the basic things or what are the basic screen that you see? So one screen that you see is the home screen or the landing screen, right? So which is the screen which you see when you land on the application. The second screen based on the application could be if it is something like irctc.com, you would see something like a book ticket screen. Then you would have a screen or a page for refund. Then you would have something called packages, which where you can see what are the tourist packages. Next, you could see what are the trains which are available, or then also you could see some offers which are there. You could also have a screen or a functionality or a page for login purpose, or you could also have a page for say complaints, and any of these kind of features. So I'm just giving you a simple example of IRCTC just to make you understand. So what happens over here? What I mean by modules, components, and all. Just let's try to understand it at a high level. So when you take, like as on today, my IRCTC website can have these many pages or these many screens. So that is what is the understanding right now. So one way of doing it is, if I am just a naive developer or I don't really understand how to do it, what I will do is I'll just create one simple Angular application. And what I will do is I'll just write the code in such a way that all of this is just dumped in one single file. And whenever the user is clicking on any of these links, I just load that particular code into my UI and my application works. So this is one way of doing it. And this is also called as the monolithic way of doing it. So what is a monolithic is? This also could be a potential interview question, like, how can you write better applications? So you should say that I won't write monolithic code, rather I would decompose them in a modular fashion. So what it means is, instead of if I have a very large application or even for that matter, a medium complexity application, I should not be dumping all the features into just one particular file or one particular class and, make it tightly coupled. So if I put everything in one particular file, also another issue is I'll be tightly coupling all of these code, because since I'm putting them in one particular file, definitely there would be scenarios where changes to any one particular screen might impact other and so on and so forth. So that is one of the disadvantages of using monolithic architecture or monolithic way of doing it. So what is the other way of doing it? Let's try to understand. Okay, so let's try to understand how can we do it in a modular fashion. So when I mean by modular fashion, what I mean is, let's say we have 10 screens which we defined earlier, right? So say I have these 10 screens which I require. I'm not writing the names again because I hope by now you'd have understood, the home, login, so on and so forth, right? So assume that I have now 10 screens. So what I mean by modular fashion is, each of these screens, I can compose it as a particular module. Okay. So just assume I have 10 screens starting right from my home page, say to the last module, which could be say like complaints. So what I can do in this scenario is, instead of writing a very big application with everything in one page, I can break it down first into high level modules. Modules are nothing but you can just assume like it is just a container which will contain the bunch of logic and bunch of code which is required to render that particular screen. So for example, in my home module, I would have all the logic and all the code which is required for me to show the home screen, the home page. And also, mind you, it does not mean that, if I have something called a home module, it will just have like one HTML file and that HTML file will contain the entire home page code. No. In the next session, we'll also cover how we can further break this down into multiple screens or multiple components. But for now, just assume just understand that every screen of your application first can be broken down into a particular module. And this module concept does not only applies to your screen, It also can apply to the features or some shared or common functionalities which are available. One example I can give to you. Say across your application, definitely for all the modules, you'll be doing some common items. Like say for example, you could be making an API call, right? Making API call is a common feature across the module because definitely you'll be interacting with your backend database server to get fetch some data. Similarly, if you're using some analytics in your application, where you want to understand how much time the user is spending in each screen, what are the links that they're clicking, and you want to send those kind of analytics to the backend server. Even this is kind of a common shared feature across your application. Similarly, there could be some common HTML components or HTML features you're using. Say for example, you have designed a button or you have designed a drop down or something like that, which can be reused across your application. So in those kind of scenarios, what you can do is you can also have a separate module which contains all these features. You can maybe call this as shared module, which is not directly a screen, but it is more like a shared feature or a shared helper module which is created, which can be then be imported to any of the module to avoid the code duplication that may occur, right? So this is what I mean by modular fashion or module. So what Angular helps you to do is it helps you to create all this module in a fashion in which you can just break down your application to individual modules, and inside then each of these module you can define your own bunch of components, your own bunch of directives, your own bunch of templates, your own bunch of pipes, services, or whatever you require. So each module can have its own files and own structures. So that is what is being shown in the diagram over here. What it says is this module has a component and this module has a service. This module can have its own value, which is nothing but a variable. And this module can also define its own function. So what it means that every module can have its own set of components, which internally will again behave in the same fashion. And also remember one thing, that each of these modules doesn't necessarily need to be loaded at the same time, because as I said, say if you're developing a site like IFCTC and you have say like something like 10 or 100 modules, if you load all of these modules at the same time, your application will become slow, because definitely from your network you have to fetch all these files, then your browser has to render it, parse it, show it. So what is the best practice that Angular follows, or we can do in Angular, is we can just load the current route or the current page which has to be shown, and only when the user clicks on some other module or some other screen, we can dynamically make the call to the server to fetch that particular module and show it on the UI. So this concept is called as lazy loading. We will cover lazy loading down the line, but just for now, you can just understand whenever you write any new Angular application, always ensure that you are using lazy loading. So lazy loading, just to recap, it means that instead of loading all the modules at a single time, you will dynamically fetch and load the modules only when the user goes to that particular view or particular screen. Okay. So I hope with that you are now kind of fairly comfortable with the architecture of Angular. Don't worry if you don't still understand what is component directives services, because we have not yet gone in depth to it. We'll be covering those part in detail in the upcoming sessions, right? And one more thing which we have to talk over here is something called as event binding and property binding, right? And for that, I will again go back to the code which I showed you in the previous session. Okay, so now let's come back to this code and try to understand what is event binding and property binding. Okay, see, event binding means if I type something over here, so this is called as event binding, which means the user is performing some event and that event gets triggered from the HTML to your component. Your component, if it requires, it can do some changes, and then that particular change can update your model and trigger a host of other events as well, right? So this is called as event binding, which means any user event on the HTML which gets triggered and captured and triggered by your component. The second is called as property binding. So what is property binding means is, say you want to change certain aspect of your element in the screen, maybe the shape of the object or the color of it or some dynamic properties of it. So those are called as property binding aspect of it. Okay. And how can you differentiate whether it is a event binding or a property binding? There is you do it normally using these brackets over here, which you can see over here. So for NG model, this we'll understand what is NG model in due course of time. But for just understand that there is a property of Angular called NG model, and it uses one angle bracket and one square bracket. So how do I know like which attributes are event like property binding or event binding? So any attribute name which like enclosed with a square bracket, those are called as property binding. And any attribute name which has kind of round brackets, those are called as event binding, right? And if there are any like for a few attributes like ng model, they use both of them. So when you use both of it, it denotes that you are using two-way data binding. So what happens is when you use event binding, it means that from your HTML you are updating the model, and when you use property binding, it means that from your model you are updating the view. So this is what is kind of the use of property binding and event binding. Don't worry, we'll be covering this in detail when in the due course of time. Okay, so coming back, I hope now you guys are quite clear on like what we have understood by the Angular basic building blocks in terms of what is a component, what's a directives, how can we destructure them into modules, so on and so forth. So with that, we'll take a short break for this session and we will resume with the final session of this week. Thank you.